Future exploration missions are dependent on astronauts having a robust immune system to minimize the risk of infection among crew members. An investigation on the space station is studying how microgravity affects the immune system, and Lori Meggs is at the Payload Operations Center at NASA's Marshall Space Flight Center to tell us more about that. Lori?
Well, nobody likes to get sick, especially when you're hundreds, even thousands of miles away from a doctor. That's why the health and immune system of crew members on the International Space Station is so important. The Salivary Markers investigation is looking at the immune system and the effects that microgravity may have on it while crew members are in orbit.
The reason we are flying this experiment is to try and figure out if there are any clinical risks to the crew members associated with prolonged spaceflight as it affects their immune system. So we are looking for manned missions to Mars in the future. We know that certain crew members, when they're on board the space station or when they flew a shuttle in the past, there is evidence that their immune systems are dysregulated. We need to ascertain whether or not these dysregulations in their immune system relate to any clinical risk before we can send man on future missions to an asteroid or Mars. The crew members on board the space station are required to provide us with biological samples. So we are collecting saliva, urine and blood samples from the crew members before they go on the station, when they're on the station, and then we'll also collect samples from them when they return to Earth. So when they're on the station, they have to give us saliva samples on a daily basis. Those saliva samples get frozen on orbit. And whenever the Soyuz is scheduled to return to Earth, then we collect a blood sample as soon as the Soyuz undocks. And then we can analyze that blood sample when it's returned to our lab in Houston. Our experiment is unique because we're able to do a very prolonged overview of a single astronaut's immune system. So in the past, samples were collected immediately before flight and immediately after flight. And then, of course, there were huge changes documented in many different immune system parameters, but we weren't sure if these changes were due to just the stresses associated with launch and landing. Now that we're actually collecting samples on the station, we get an idea of what's happening to the immune system in flight, and we believe that gives us a more accurate representation as to what's happening to the immune system of these astronauts when they're on the space station for 6 months and beyond. We know from previous experiments that there is evidence of latent viral reactivation. So this is when viruses that our body are already infected with, they become active again. And there is evidence of that from previous flight experiments. Now what we're trying to do is find out if these latent viral infections actually contribute to dysregulated immunity and whether or not that contributes to any clinical risk to the crew member. So the experiment is in the early stages at the moment, but by the time we complete it, we hope to have more definitive answers. The space station is ideal because the crew members will be in microgravity for at least 6 months. So it gives us an idea as to how microgravity or just the overall spaceflight environment can impact the immune system. And this is obviously very important as we prepare for exploration class missions to see an asteroid or Mars. Now the crew members are also under a lot of stress. They're in isolation. There's a lot of physical and psychological demands placed on them, and that will impact their immunity. So it does have the potential to benefit terrestrial research on Earth also.
Dr. Simpson tells me 3 crew members have completed the entire study protocol, and more will as the study goes on. It's expected to be completed in May of 2016. And you're looking live at the Payload Operations Integration Center. Busy today. Denise Morris is the Payload Operations Director today, and they are assisting in some of those coordinating studies in the microgravity science glove box that you've been talking about, Brandy. And that'll do it for us here at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.